Did you see this? I haven't watched this yet, but I actually have no idea. I know a little bit about the old C, but this one is one that I cannot understand why.
I was talking with a coworker at work today. He's kind of a C fanatic, and he likes doing weird stuff in this language. He showed me something kind of cool and interesting, and it kind of blew my mind. So I'm going to share it with you today. This is a very basic C program. I'm writing in C99 right now, but it doesn't matter which version you're using. It's simply a main function that declares an array of 5 elements, and the 5 elements are 1, 2, 3, 4, 5. And then we loop through this array from 0 to 5, so we loop through every element.
Boomer loops. Look at this boomer loop doing that. Why didn't you do a for each on it, huh? What is this boomer loop boomering? Okay.
We print each element using the printf function, and we access each array element using the simple array access operator here, the square brackets. If we run this program, it should give us a very predictable result of, if you look down here, 1, 2, 3, 4, 5. So this is the normal way that you would see an array printed to the console. But what if we
classic normal way? Okay.
Changed it to this instead?
I would tell you that this doesn't make any sense. That this isn't real, this is fake, and I don't even know how to understand what I'm doing.
What does that even mean? It's a little bit weird, isn't it? Because now we're saying, from a semantic perspective, the array itself is the variable I, which is just it's just an integer. And then we're accessing the array inside of that. So does that mean we are treating I as an array and then the address of the array as the elements we want to access? Or what does that mean? So do you think that this should crash, or what should happen? Maybe a runtime error? If we go ahead and play this program, it actually prints out 1, 2, 3, 4, 5 again. Very strange. Why does this happen? If we look at the C99 spec,
by the way, you know you're in deep when you're looking up the spec. Okay, so the classic C language spec. By the way, which is this is one of the few languages that you could actually look at the spec and understand what's happening.
Online, we can see this paragraph here about postfix operators. The definition of the subscript operator is that E1 of E2 is identical to this expression here, and this is the key point. So I added both.
Oh my goodness! What? Okay, for those that didn't see that, it's just E1 plus E2, and then you just deref that son of a bitch. That's crazy. Yes, because it makes no sense. I don't get it. It just means this. Here, I'll rewrite it. I don't know how you don't. Honestly, I don't know how you don't get it from that. So when we do something like this, R-I, what it's saying is that, let's just say that R exists somewhere at hexadecimal, 5 something, okay? Let's just pretend it's somewhere. That means it's literally doing hexadecimal 5 something plus I, deref that, right? Which means that if you were to flippity-floppity this thing, you're going to get I plus 0x5 something, deref that son of a bitch. Yes, there is this. There's an implied thing, by the way. For those that don't know, there's actually a multiplied by the width of the array, size of the array, right? So since this thing is an int array, and let's just pretend the int is 64, bits, it would then be 8 or whatever it is, right? Okay, it's so simple that it's painful. I cannot believe that, because you saw right here, E1 subscript E2 is identical to that. So in other words, what both of these phrases are saying is literally I plus array, right? That's it. And then you just deref that. And an array, for those that don't know, they're just a pointer. It's just a pointer. That's all it is. That's life in the fast lane.
Key points. So I added both versions of this to the code, and you can see the only difference is where the I and the ARR are in these expressions. Because of the way that this is unraveled by the compiler, it doesn't actually change anything.
I know it's not technically a pointer, but it's easiest to look at it as a pointer, okay? Just keep it simple. Just call it a pointer, and your life will be 99% of the C99% of the time nice. And for those that are actually doing C99, you know the difference. And for everybody else, you don't know the difference. So just keep it simple.
In this first one, we're taking the address of the first element of the array and adding the integer onto it. So we do some pointer arithmetic to point to the next elements. And it's the same thing at the second one. Because addition is commutative, it doesn't matter which order these are in. They both do the same thing. Of course, in practice, you probably don't want to do it this way because, like I said, semantically, it doesn't make much sense. And actually, at work, we have code bases that are multi-million lines of code long. And we joked about going through the code base and just changing all of the array accesses to this version right here. It would be really confusing for everybody because semantically, it makes no sense. So you probably want to do it this way instead. And that's all for this video. Thank you for watching.
That was fantastic. Give this man a like and subscribe here. All right, well, now that we've just thoroughly had our mind blown and I don't even know what to do with this information, I guess I'm just going to say, here's a bit of information you'll probably never know exists, but it's amazing. And, oh, it's called real engineering. Real engineering, suffering from memory problems. At what point does it become real engineering? When the gatekeepers, when rockets, scalability, these nuts, when you involve something physical, when Scrum is involved, when it breaks prod, math, ABET accredited. When HR says that's your new title, when programming meets time management. Okay, well, it sounds like none of y'all have an answer to this one, okay? Sounds like none of y'all know nothing, okay? Looks like, what, Prime, am I an AI to you? Yes, you are, Devin. Devin Little, you are an AI to me, okay? Devin, nice job choosing a stupid name. Maybe you should go back to your mom and be like, oh, you chose a terrible name because in the future, my name sucks. Again.